Okay, the third and final example with critical analysis and linear regression, we're looking at detecting hidden variables. Okay, this is when there's a relationship there, but there's something that's playing a key factor, and it's just a matter of sort of narrowing it down. So an arts council is considering whether or not to fund a startup of a local youth orchestra. Council has limited funds and wants to know the investment will benefit young players. One measure of success is the number of youth orchestra, that should be youth orchestra players who go on to professional orchestras. So the following data was presented to the council. Someone went out and they made this T-chart up. It shows the number of youth orchestras, and then it shows the number of the players from those youth orchestras going on to professions in that field. So A, does a linear regression allow you to determine whether the council should fund a new youth orchestra? Can you draw conclusions from other analysis? So let's figure this out. The way it's set up right now, I would say that the X variable, or the independent variable, is our youth orchestras, how many are out there. And then on the y-axis, the dependent one is how many become professional. So what you want to do, you want to grab the graphing calculator and want to enter this data in. Now I did this already, so I'm all set to go. So I'm looking at the data right there. And what I'm seeing at this point is not a whole lot, because I got to get it plotted into the scatter plot. So looking at my x-axis, I see that it goes from 0 to 16, so I want my window to go from 0 to 20. Similarly, the y-axis, there's mid-30s, so I'm going to have my y-axis go from 0 to 40. Continue on to scatter plot. I get something kind of interesting here. So the question is, based on what I have in front of me, hey, is there a linear relationship? Well, it's kind of funny how there seems to be two unique groups of data here. Okay? So a couple of impressions. Could our line represent the data? And the answer is no. You could do it. Okay? Maybe some people are thinking, hey, if I draw a line down the middle, it's representative. But when you look at it, the pattern shouldn't be like that when you're doing a line of best fit. Some data points should touch your line of best fit. So that's what tips me off that our line of best fit won't work here. So what does that mean? There has to be something that's playing a role here. So this is number of youth orchestras, and on the y-axis is professionals. So something has gone on. Now, hopefully some of you are saying, well, it's kind of two lines maybe. Okay? That may be a possibility. All right, we're going to have to talk about that a little bit further. So before we go any further with that, let's take a look at time. So instead of looking at the professionals and, where's my calculator here? We're going back a page here. Rather than looking at having youth orchestras on the x-axis, let's switch it over and let's put a timeline on here and then compare it to professionals. So I'm going to change my calculator setting. I'm going to have year 0 or year 1 as 1991 when I enter the data in, and I'm going to put professional players on the L2. So I'm going to plug that in and see what happens. Okay, so as I mentioned what I was going to do, I've changed my calculator, so I've changed the x-axis to years now. And like I said, 1991 is going to be a 1, 1992 is a 2, and my x-axis are the L1 column. L2 column, I'm just looking at professionals here. So I want to see if time and professionals make a difference. So I got to change my windows. So I've got to go from 0 to 10 because I'm looking at a period of 10 years. And when I look at, the Y column, I see again, I'm not going to change it because it gets roughly 40. So 0 to 40 is fine. So I'm going to do the graph. And again, I get this repeating pattern of two things going on. It looks like two different relationships or two events are occurring. It's like you have data from two separate events. So I'm just going to put, again, it's a similar pattern. Similar pattern. It's like we are looking at two sets of data. So So what that tells you is that something's going on. There's something that's occurred here that has created this disjoint, okay? There's not a continuum between the two. So we go back to the original question A. Does linear regression allow you to determine whether the council should fund a new youth orchestra? So at this point, I'd say for A part, no. Some factor is affecting the data to create two distinct data groups. So no conclusion can be drawn at this time. All right. So when you look at the original analysis up here, that original analysis that we did here, talking about number of orchestras and professionals, we see that there's two distinct data sets there, and then we changed it. Instead of looking at youth, let's look at professionals over time. So something has occurred here. We've got a split in the data. So if I was going back to the council, I'd say based on what you gave me, there's something going on here beyond youth orchestras and professionals, because it's creating two sets of data. So that takes care of A part for us. You've done a bit of an analysis, and you've drawn a conclusion, and you've identified something's going on. B part. Suppose you later discover that one of the country's professional orchestras went bankrupt in 1997. If we look back at our graphs that we created, 1997, I know it doesn't show here, but 1997 is right there. So you got 1, 2, 3, 4, 5, oops. Yeah, that's right, 7, so I'm off a little bit. So in both graphs at 1997, that's where the problem is. So that's good to know. You've identified, hey, something did happen. Now what happens when a professional orchestra folds? Okay, they went bankrupt. That means they're disbanded. That means that you have professionals that do not have work. And technically in this case, when you count up how many professionals there are, you're counting up how many are actually working as professionals. So unfortunately, the poor individuals in that particular orchestra lost their jobs, which slides them out of the classification of being a professional since they're not playing. So how does this information affect my analysis? Well, that tells me that I can analyze my data up to 97 before the collapse of the orchestra, and then I need to analyze it afterwards. So the before and after scenario, because I know 97 there was a huge event to discontinue the data. So what I'm going to do is I'm going to enter it as two different data sets. I'm going to put my before in, and I'm going to put my after in, and I'm going to analyze it. So I'm going to take a second, I'll enter the before into the calculator, do the analysis, and then we'll do the after. Okay, so I've got the data entered in. I'm looking at my list now. So I only did from 10 to 14, so I did from 91 to 96 and entered that data in. I changed my window to 0 to 40, 0 to 40, and created a graph. And now I'm thinking, man, that looks a lot better in terms of a relationship with only one piece of data, one group of data. So now if I go ahead and do my analysis here, and it looks linear to me.
Excuse me, please. We have a customer come to the office for a message. We also have others in the office for supporting event work.
So now when I look at the calculator results, this is the new window. Now when I'm looking at the results here from the calculator window, now I have an R factor of 93 or 0.93, so that's a lot better. So the first group before the collapse of the orchestra, looks like a fairly strong relationship. So strong positive correlation. And now I'm going to repeat it for the second part. So I'm just going to take a second to fill it in with the calculator with the second part. Okay, now when I enter in the second piece of data, or the after, there's only 4 pieces of data. However, there does appear to be some form of linear relationship. And when I check that linear regression, I also get a very strong correlation. So I'll just copy that quickly. So now when I'm looking at it, I've got a strong correlation after of 0.98. So if I knew this information during my analysis, now I can draw a conclusion. So based on the collapse in 1997, the remaining data would support a strong linear correlation between youth orchestra and becoming professionals. So now I could go back to the committee and I could say to them, hey, if you ignore the 97 year where things went down the tank for that professional orchestra, and we look at it a before and after, we can see definitely there is a direct relation or direct correlation. So spending the money on the youth orchestra, yeah, I would support now based on the data that was provided. So you need to use your critical analysis skills when you see funny things happening. And what I mean by funny, when you see groups like this, you don't want to be forcing the issue. If you don't believe there's a line there to be found, take a step back and ask yourself, why is it like that? All right, so good luck with the examples. I have the homework here in the textbook. Using the graphing calculator, you can use the spreadsheet software as well. All right, if you have any questions, please let me know.